This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005.
Now, percentages can be applied in, apart from several situations, two specific situations where we could be asked to compute the percentage error. Now, finding the percentage error, the formula for finding out the percentage error is the error amount divided by the correct amount. Now, please make sure that you divide the error amount, the delta, by the correct amount multiplied by 100%, right? So, if let's say I were to take an example that there is a 5-meter rod, a 5-meter rod is measured using a measuring tape, right, which shows a reading of, let's say, 5 centimeters. So we have to find the it shows a reading of 5.05 meters. So sorry, 5.05 meters, right? So if this tape is showing a reading of 5.05 meters in calculating the length of a 5-meter rod, right, then the error is 0.05 meters, which is the difference between what the tape is showing and what the actual length is, right? This we are going to divide by the correct length, which is 5 meters, and then we are going to express this in the form of a percentage. We get, this is 1 upon 100, right, and this is into 100%, so we get 1%, right? So error percentage is computed by the change, the error, divided by the original amount multiplied by 100%. Similarly, we could be asked to calculate the percentage change. Now, in calculating percentage change, what you have to do is find out how much change there has been, right? So change in the original units divided by the original amount, right? Please make sure you do not put the new amount after change in the denominator. Please put the original amount multiplied by 100%. So if let's say there were 20 people in the room to start with, then there are 2 more who come in. If we have to find the percentage change, then the number of people who have come is 2. The number of people originally in the room is 20 and not 22, multiplied by 100%, which is equal to 10%. An important concept in percentages is constancy of product. Now let me explain what the situation here is. Now let's say we have, I'll start with an example. Let's say I have $50. If I have $50 to spend on a certain article, right, then the situation is, and let's say I want to buy oranges using $50. Now if if one orange, it costs $1, that means using these $50 I can buy 50 oranges. The number I can buy is 50, right? However, this is one situation. However, if there were another situation such that one orange now costs half a dollar. In this case, the number of oranges that I can now buy increases to 100, right? The whole point is that the amount of money, the amount of dollars I have in my pocket to spend on oranges is a constant. So if this were to increase, this goes down and vice versa, right? So essentially, if we express this in another way, the price per orange, right, if I call this variable as x and this variable as y, then x is inversely proportional to y. The idea is, if x reduces, then y increases. If x increases, then y reduces, right? or x equals a constant upon y, or x into y is a constant, right? So this situation is constancy of product, right? The product of two entities being a constant. Now, how do we handle situations like these when we are given, we are given an x and a y, and then we are asked if x changes by a certain percentage, what is the percentage change in y? So let's do this using an example. Now let's say there is a situation, we start off with this basic situation. So $1 multiplied by 50 is a constant, right? That's the $50 I have in my pocket. However, if let's say I were to change the $1 to $1.25, right? Then how does the new y, what is the new y? Right now, clearly the new y is $50 because that's all I'll spend, divided by $1.25 per orange, right? So I get 40 oranges, right? Now 40 is 10 fewer than the original 50, right? Or in other words, 40 is down by 20%. So you notice that I've increased x by 25% and y has gone down by 20%. It has not gone down by 25%, right? So what is this change? How is this change 25% related to this change of 20%, right? Now, if let's say one factor increases by x percentage. Now I'm using x for another thing, right? So now if one factor increases by x percentage, then the other must reduce by x upon 100 plus x into 100%. This is the percentage fall in the other variable, right? And vice versa, if let's say one factor, it reduces by x percent, then the other must increase by x upon 100 minus x into 100%, right? So let's take an example. So if let's say the price per orange has to fall to 80 cents, right? So $0.8 is the new price per orange, right? So this is a fall of 20% over the original price of $1, right? So this 20%, if I have to find out how many more oranges I can now buy, my answer is going to be 20 divided by 100 minus 20 into 100%, right? So this gives us 20 upon 80 multiplied by 100%, which is 1 by 4, which is equal to 25%. So a fall in 20%, fall in price per unit of 20% will result in 25% more entities that I am now able to buy.
Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.